Good afternoon.
Good afternoon.
And welcome to the fall quarter. This is Math 2B Calculus. And my name is Natalia Komarova. I'm a professor here at the math department. And I'll be teaching you this subject. First, I want to go over the basics of this class and tell you a little bit about how this is organized. First of all, I have created a website with all the information already contained on those website pages. But today I'll still spell everything out for you. So first of all, the textbook. So this is probably the most confusing part of the whole thing. So it's called Calculus Early Transcendentals. So it's 7th edition of Calculus. Early Transcendentals by Stewart. So the most important part is early transcendentals. There's a 7th edition that does not contain these words. Look at your book. If it doesn't say that, that's a wrong book. Now, there's various shapes and forms of this book. For instance, what I have only contains single variable calculus. So that's good for 2A and 2B. And so that'll be fine for this class. There's also a bigger book that has, parts that pertain to other classes. Like if you're planning to take 2D or 2E, you should get the full book, the big one. There's also an electronic book, okay? And so there are many questions that people ask me over email. Is it okay to use a second-hand copy? And the answer is yes, it's okay. If you bought your book from a friend, if it's used, and your electronic stuff doesn't work, if you cannot create an account, that's okay. All you need from this book is the chapter material and the homework problems. Okay, so I do not require you to buy a new copy, of course. A second-hand copy is okay. Any questions about the book? Okay. So now, exams. We're going to have 2 midterms. On October 18th and November 8th. And we're going to have a common final exam. Question?
Would we need to bring our book to class?
No, absolutely not. No. So common final. Which is held on Saturday, December 7th, from 1 to 3. So I'll tell you a little bit about the common final, but first I note that according to the policy of the mathematics department, you are not allowed to use books, notes, or calculators during any tests. So it's a closed book test, no cell phone, no calculators are allowed. What's the common final? If you've taken 2A, you know what that is. It means that you come here on Saturday, okay? And it's a common final that's held across all the sections of this class. So there are unique requirements for everybody. You have to produce your valid UCI ID card for the midterms and the final. You have to make sure that you have an ID, and you also have to make sure that you're recognizable on that picture. So very often students produce something that looks like this, with just a circle instead of a face. So make sure that you get your ID replaced, such that your picture is recognizable. So another thing about common final is that if you cannot make it, you should let us know early on. and you don't let me know, you let the secretaries at the math department know. You have to fill out a form that is contained online. You have to follow the link from the website. There is a special form that, standard form that you fill out, and there should be no problem with that. They will arrange for a makeup. But of course you have to have a valid reason not to attend the final. Questions about the final? Justin?
Do we need to scan John's or the blue book?
No, nothing like this.
Okay.
I will provide a paper copy of the exam, and all you need is a pencil and an eraser. Yes?
When you said no calculator, are we allowed to bring like a simple calculator?
No.
To hands?
No, but we always make sure that you can do all the math in your head.
Yeah.
Okay. There will be nothing horrible. More questions?
Will a calculator be needed for the class?
No. No. You can use it when you do homework, of course, but in class, no. Okay. So now, some other assignments that we'll have, apart from the midterms and the final. We will have homework, okay? So the way it works in this class is homework is optional. Which means that it's not graded. Nonetheless, this is probably the most essential part of this class, because everything that you're tested on is based on this optional homework. Okay? So the list of homework problems is provided on the website of the class, and it goes by section number. So for instance, section 6.1, and it gives you a list of homework problems. So you sit down and do as many as you can after we have covered the material. If you're fine with all the homework problems for each section, you'll get an A+. Okay? If you're fine with most of them, you'll get an A, and so on. So this is your way to study. Do the homework problems. Nobody will test them directly, but we will have quizzes. Okay. Quizzes are held once a week at the discussion session on Thursdays. And the quizzes are completely based on the homework assignment for the previous week. Okay? So if you've done your homework, you'll know how to do your quiz problem. It's either just a homework problem taken from the list, or something that is very, very close to it. So in order to prepare for the quiz, you have to do the homework. And the quizzes are graded. Okay, so this is graded. Now, another part of assignment is web work. Can you raise your hand if you know what the web work is? Do you know what it is? Oh, I see. So you're not familiar with this. So this is an online homework assignment. So on the website for the class, I created a link that takes you to the web work homepage. This page is not active as of now. They'll activate it in about 2 weeks when the first assignment is posted. So the first assignment will be posted on the 10th of October. Okay, so until then you don't have to worry about it. So you go there, you log in, and you do your problems. There will be 8 web work assignments during the fall quarter. There will be every week, posted on Thursday, and due the next Friday. The first web work assignment is based on the problems from the beginning of the class, and they're cumulative, such that later on, web work problems could test your knowledge from far long ago. So everything that you have studied up to that date can be tested with web work. Each assignment has a varying number of problems. And I posted the full schedule of all the web work assignments that is already known now. So you will know the due dates and the dates when these things are posted. You have an extension for Thanksgiving. Okay? For Thanksgiving week, you have a little bit more time to finish. So there are a few things that you need to know about web work. So among the class files, I posted a PDF file that tells you about web work. So one new thing that they told us about this year is that somehow it doesn't work very well from, so it works very well from campus, when you're on campus. If you're away from campus, you have to use VPN to connect, and the instructions of how to set it up are given on the website of the class, okay? And there are various quirks associated with WebWorks, because sometimes you may type something in the wrong font, and it thinks that you made a mistake. All these things, please read what I posted. It gives you a lot of information. And so if you experience technical problems with WebWorks, please do not email me, because I will not be able to help you. I can only confuse you if you ask me technical questions about the website setup and stuff. Email them. There is an email address provided on the website of WebWork, and they'll be able to resolve your technical issues. If you have a problem with your mathematics, then I'm your guy, okay? Email me and or come to the office hours, and I'll be able to help you with any math problems, okay? But not with technical problems and website problems and stuff like that. Questions? Okay. Grade. Consists of 40% final, 20% of each of the two midterms, 10% web work, and 10% quizzes. So the lowest quiz and the lowest web work are dropped. So one lowest drop. And here the same. Because of this policy, there is no possibility to make up for quizzes or web work. There is one seat here, if you need to sit down, and there is also one over here. If you haven't, there are also two seats over there, in the middle. Okay. So if you miss a quiz, or if you miss a web work, don't worry about it because of this. Okay, you have a chance to miss one. Question?
So is the WebWorks like an online quiz, or is it like an online homework assignment?
It's like an online homework assignment. I think you have an infinite number of attempts to solve a problem.
All right, yeah.
More questions?
Will we be able to use a calculator on WebWorks?
Oh yeah, you'll be doing it at home. But not during quizzes. So quizzes are like exams. More questions? Okay. Now, I think the last thing is this. So, early transcendentals. So what does it mean? It means that if you took Calculus 2A prior to fall 2012, you will have some catching up to do. So the mathematics department has changed the syllabus. We used to teach things like logarithm or arcsine or e to the x. We used to teach that in 2B. Now these things are taught in 2A, and you're supposed to know them. You're supposed to know these things, and you're supposed to know their derivatives and their calculus. Okay? You have to know what they look like. You should be able to plot them. So how many of you have not seen those before? Okay, very good. So that's good. However, if you want to refresh your memory about these complicated functions, there is some online video material. You can watch some videos and refresh your memory about these things, such that you're well prepared for what we have here. Okay. Instead of these things, we'll be studying sequences and series, which are much more fun. They are. I've taught those. This is better. This is better. Questions? Okay. Question?
Are the tabs going to be curved?
No. So there is no curve. There's going to be a standard grade So the finals are graded across the whole, all the sections. Then if they think that it was too hard or too easy, they are going to uniformly, add some points or multiply it by a factor, so everybody gets the same treatment. And then after that, there's no curving. Okay. Also, there is no extra credit. There's nothing you can do but do the homework. Okay. But so everything is very straightforward in this class. All the information is in the homework. If you have questions, if you don't understand something, come to my office hours, which I will announce next week. I don't know yet when my office hours are, and then we'll be fine. Question?
So if the average is low, is the final curved or the class is curved, like all overall?
So if they think that the common final was too hard, they're going to kind of boost that grade.
Just for the final, though?
Just for the final, yeah.
So you don't curve in this class?
No,
Okay.
and I'm not supposed to.
Okay.
What's the website?
What's the website? I think you can find it on EEE.
Oh, okay.
Yeah, there's a link. Also, you can go to my home page and there's a link from there.
Alright.
But it's easier to go from the EEE.
Just to make sure, you said the web work is due on Friday. That's the following week, correct?
Yes, it's posted on a Thursday. It's due the Friday next week. So it's the following week, yes. So you have a week and 1 day to finish it. More questions? Okay. And you can always ask me any questions during the class. Just raise your hand, okay? So now we do some review of some essential stuff that you learn in 2A. If you cannot see something, please let me know, so I avoid some parts of the whiteboard, okay? So today we cover section 4.9, antiderivative. Okay, ready? So let's suppose that the derivative of function capital F is given by lowercase f for all values of x in an interval. Then f capital is called the antiderivative of f. So for example, let's suppose that f is equal to x squared. What's the antiderivative of this function?
2x.
So there you go. So there are two opposite operations. You can take the derivative, and you can go back and take the antiderivative. Question?
1/3 x to the cube.
Yes. So this happens to be one of the antiderivatives of this function. In fact, how many are there? Infinitely many. Plus c. So by adding a constant c, we create an infinite family of functions, each of which is an antiderivative of this. How can we check? So this is antiderivative. To check, we say what is f prime of x. We have to differentiate. So I have 3x squared over 3 plus 0 is x squared. Check, because it coincides with my original function. Question?
Oh, you can't see that.
You cannot see this?
No.
That's very bad. Okay. So, are you telling me that? Can you see above this line? Yes? Okay. Fine. So, we have a theorem. If f is an antiderivative of f, then f plus c is the most general antiderivative. And here c is the constant. Okay, so let's practice and do some examples. So let's suppose that f of x is cosine x. Find f of x. So basically we're looking for a function whose derivative is equal to cosine. So what is f of x? Very good. Sine x plus c. Fine. Another example. F is given by x to the n, where n is not equal to minus 1. So may I ask you please to not talk during this class? If you have questions, ask me, but not talk. So we have a rule to evaluate the antiderivative of this. It's called the power rule. Power rule. Okay, so it tells us that the antiderivative is given by this function plus c. Right? And in fact, this is the rule that we used here to calculate the antiderivative in our very first example. So I have a question. Why is it that we have to require that n is not equal to minus 1? What happens to this formula when n equals minus 1?
0.
Yes, we divide by 0. So this formula is obviously not applicable. Something else goes on there. So that's my next example. A very special case when n is equal to minus 1. So f is 1 over x. What's the antiderivative? Natural log of x. Okay. In fact, it's like this: natural log of the absolute value of x plus c. And we have to say that this formula actually holds on any interval that does not contain 0. So if I give you an interval from 1 to 5, for instance, on this interval, any such function with a constant c will serve as an antiderivative of the log. If I want to write down the most general antiderivative on the whole real line, it's something slightly more complicated. So f of x is log of x plus c for positive values of x. And it's a logarithm of minus x. I'm sorry, plus, I have to denote it c1, okay? Plus c2 when x is negative. And the antiderivative is not defined for x equals 0 because the original function is not defined for x equals 0. Question?
Could C1 and C2 be equal?
No, they can be equal, but in general they don't have to be. So this is the most general form of the antiderivative of the function 1 over x. So this function can have a discontinuity. It goes like log x, log minus x, but here when you hit x equals 0, we can have a different constant. So it's in general a discontinuous function. Okay. Very good. We also have something like this for negative values of n. So let's suppose that f is x to the minus 4, right? So now we have a very similar situation. So by using the power rule, okay, my power is minus 4, so I have to x minus 4 plus 1 minus 4 plus 1, right? It's x minus 3 divided by minus 3. So the most general antiderivative is given by the following discontinuous function. So the antiderivative again is not defined for x equals 0 because the function itself is not defined there, and it may experience a discontinuity as you cross 0 because we are allowed to take different constants for negative and positive values of x. So what we need to know for this class is a list of antiderivatives. It's best to know those by heart. So we have a table in the textbook that goes like this. We have a function, and we have a particular antiderivative. So what are the most common functions that you should know by heart? So first I list a rule. If you have a function f, any function f, multiplied by a constant c, so the antiderivative also gets multiplied by c. You know that, right? And similarly with the summation, the antiderivative of a sum is the sum of two antiderivatives. Now, particular examples of functions. We already listed some of them. Here I do this for completeness. So I'll continue this table here. Let's do cosine x gives me sine x. So this is f. This is sine x. Negative cosine secant squared gives me tangent secant tangent gives me secant. These two follow from the definition of the derivatives of secant and tangent. Right? If we know the derivative of this, that's equal to this, then the antiderivative of this is this. This table works both ways. To go from here to here, you have to take a derivative. To go from here to here, you have to take the antiderivative. What else? Here. We have something that is associated with arcsine and arctangent. We have the log, and so this is the best one. Why is it the best one? It's equal to itself, right? It's the easiest one to remember. The exponent is equal to its own derivative. Also, it's equal to its own antiderivative. Questions? So let's practice. So a simple common problem that we encounter is find the antiderivatives of functions, right? So find all functions g such that g prime is 5 plus cos x plus 3x squared. So look at this function. We'll go to the table. Of course, we don't find that function in the table. However, if we simplify this function, we'll find its components in the table, right? So the first thing here is to simplify it, and then we'll be able to use the table. So I'm going to say that this is 5 plus cos x, and here I divide through by x, so I have 3x plus x minus 1/2. Okay. Now each of the components here can be found in the table, and I'm going to use the table. So g. So the derivative of g is this. Therefore, I have to find the derivative, the antiderivative. So it's 5x, okay, plus sine x. How did I get the first term? We will learn how to integrate in this class, but we have to find an antiderivative of a constant. So where can we find that? For example, here, if n equals 0, that's a constant 1, right? So n equals 0 gives me x to the power of 1 divided by 1, so that's x. So the antiderivative of 1 is x. And here, this tells me that multiplication by constant just carries through. So this number 5 appears in front of the antiderivative. Okay. Sine is the antiderivative of cosine, just follows right from the table. This one is easy. Again, that's a power function, so it's 3x squared over 2. This one is also easy, because we use the same rule, power rule, only now we don't have an integer power. The power is equal to minus 1/2. So we have x 1/2 divided by 1/2. And then don't forget plus c. This usually costs 1 point at any test. Okay, questions?
Do we have to simplify the 1/2 to a radical, or can we leave?
When it's easy like this, probably. I wouldn't take a point off for this, but different graders are different. Okay, the next question is a little bit more sophisticated. We can talk about differential equations. In itself, it's a huge topic, and there are whole courses taught on this, but I'll just show you what it is. So the problem is like this. Find f if f prime is equal to x to the 6 and f of 1 is equal to 3. So I need to find the function f given this information. Two pieces of information. The first piece of information pertains to its derivative, right? And the second one tells me what the value of the function f is at 1 point, x equals to 1. So that's what I need to find. So from this equation, I can find f by looking at the most general antiderivative. So general antiderivative. I have to take the antiderivative of x to the 6, which is x to the 7 over 7 plus c. So I found a whole bunch of functions f. They all differ by this constant. And that is why I'm given the second condition. This condition will help eliminate most of these and zero in on the relevant one. Okay, so use f of 1 equals 3. How do I use that? I plug it in, exactly. So I go f of 1 is 1 to the 7 over 7 plus c, and that's supposed to be equal to 3. So I can say that 1/7 plus c equals 3. Or c equals 3 minus 1 over 7, which is 20 over 7. Therefore, my function f, not the most general one, but the actual function f that solves both of these, okay, that's given by x to the 7 over 7 plus 20 over 7, or x to the 7 plus 20 over 7. So out of all of these functions, I identified the one that satisfies not only the first equation, but the second one too. Questions? Okay, so now we will refresh our memory with regards to graphing antiderivative. And we'll talk about the notion of velocity. So let's suppose that the function f is given graphically. Something like this. 1 second. So it starts off here, goes negative, four. Like this, and like this. Okay, something like this. Let us sketch the graph of the antiderivative. So no formulas are given, and I want to draw f capital. So how do I do this in principle? This is a derivative of this function. Now remember, what is an antiderivative? What is a derivative? The derivative is this rate of change. It's the rate of change. It's the rate at which the function changes. If we think of the independent variable as time, the derivative is how quickly that function changes. Okay? It tells me the slope or the rate of change. And the rate of change can be interpreted as a velocity. So let's suppose that this is a velocity of motion. And as you can see, as time goes by, it changes. Sometimes we go faster, then we slow down. Okay? At this point, the velocity is equal to 0. And here it becomes negative, which means that we go backward. Right? Then, after this point, we again turn and start going forward. So by using this information, I'm going to draw the position given the velocity. Okay, I have to recreate the position given the velocity. I start with some arbitrary point. Okay, let's suppose that we know that we start at 1. And now, so look, the velocity here is positive, which means that I'm going forward. I go forward means that my position, the coordinate of my position, increases. So for a while, between time equals 0 and time equals 1, I go forward, slower and slower and slower, but I move forward. So I move forward. This is my positive direction. My coordinate increases. At this point, I stop. At this point, my derivative is equal to 0, which means that I'm going to have like a maximum here, right? And now my velocity becomes negative. At this point, I start going backward. And that's exactly what I'm drawing here. I start going backward. faster and faster and faster. At point 2, my velocity is the fastest, negative, and then it becomes slower and slower and slower. So somehow at point 2 I get something like this, and I stop at point 3 because my velocity again is 0. After 3, I continue to go forward. So my coordinate increases, and then the velocity decreases. So somehow I level off. I start going slower and slower and slower, and eventually I almost stop, but never quite stop. Questions? So you should be able to take the graph of a function and draw its antiderivative. But I want you to think about velocity. Okay? I want you to think, if this is positive, this increases. If this is negative, this decreases. If this is 0, it means that I experience either a maximum or a minimum. I don't change at that point. Questions? Very good. So now, in the last problem, I think it's the hardest of all, we will talk about not only velocity, but also acceleration, because they're both connected to derivatives and antiderivatives. So the problem is like this. Suppose that the acceleration of a particle is given by this function. So here is my vocabulary. A is acceleration. V is velocity. And S is position. Okay? These are the common notations. And you know that the velocity is the derivative of the position, and the acceleration is the derivative of the velocity. Do you know this? Yes. Okay, so what is given is the acceleration and also some information about the position. At the beginning, the position is 2, and the velocity at the beginning is equal to -1. Find the position as a function of time, given this information. So I have to do it step by step. I start by saying that acceleration is the derivative of the velocity. So v prime, okay, is t plus 1. If I know the derivative of the velocity, I can find the velocity by taking the antiderivative. So v of t is found by calculating the antiderivative of this function, which is really easy. T squared over 2 plus t plus c. Right? So given the acceleration, let me just, I don't want to miss steps. So this is A. A is the same as v prime, and it's given by t plus 1. So if I know v prime, I know v. And it's given by this. Unfortunately, I have this unknown constant here. But I can fix that by saying that, oh look, v of 0 is equal to -1. That helps me find the appropriate c. So we use v of 0 is -1. So what is v of 0? It's 0 over 2 plus 0 plus c. And it's supposed to be equal to -1. Therefore, c is -1. Therefore, v is t squared over 2 plus t minus 1. So I completed the first step. Using the information about the acceleration, I found the velocity. And I also used this condition about the initial velocity. That helped me identify the particular constant c. Okay? So that's step number 1. Step number 2, I know the velocity now, but I need to know the position. So step number 2. I go here. The velocity is the derivative of the position. So v is the same as s prime, And that's given by this formula that I just derived. T squared over 2 plus t minus 1. From this, I can find the position by taking the antiderivative. So if I know the derivative of s, I can find the antiderivative. So again, I have an unknown constant called a. Okay. So what's this constant? That's the last step. I'm going to use this piece of information, the initial position. S of 0 is given by 0 over 6, 0 over 2 minus 0 plus a is supposed to be equal to 2, which means that a equals 2. So I can write down the answer. S of t is given by t cubed over 6 plus t squared over 2 minus t plus 2. So this is a formula that defines the position of that particle as a function of time. Questions? Okay, thank you very much.